Cervical cancer is one of the most common cancers affecting young women, and it's caused by a virus called human papillomavirus, or HPV, which is spread through sexual contact. The virus causes the cells of the cervix to keep growing excessively, which eventually damages their DNA, leading to cancer. Testing for this cancer can be challenging, though. These days, it involves using DNA tests to look for traces of the virus in a sample. But these viruses are very common, and only a small proportion of people carrying them will actually go on to get cancer, so there are lots of false positives. Now, though, researchers at Queen Mary University of London have found a way to tell who really is at risk by pinpointing changes to a pattern of chemical markers called epigenetic marks, which are present on our DNA. A person at risk of cancer develops characteristic changes to these marks, which study author Attila Lorentz can pick out. And he told Georgia Mills how.
In the past, we had tested with cytology, also called the pap smear. Its biggest problem is it has a low sensitivity. In other words, the ability of cytology to detect a precancer or cancer is in the range of 50 to 60%. We are increasingly testing for it now with a molecular test called the human papillomavirus test. HPV testing is much more sensitive. In other words, it can detect 90 to 95% of women who actually have the precancer.
Right, so where does your work come into this? What have you discovered that's going to make testing for cervical cancer easier?
Okay, so the crux issue is that human papillomavirus is incredibly prevalent. In other words, it's very common. It's estimated that 80% of people in the world have been infected with HPV at some point in time. Lucky for us, our immune systems get rid of most of this. Otherwise, we'd be literally covered with warts and cancers. This is a very old virus. It lived with the dinosaurs. It evolved with us, but it's very common, and mostly it just likes to hide away and not be found. However, the HPV molecular test is so sensitive that it detects a lot of these, and this causes a lot of anxiety. So there's a downside to that much greater detection of 95%. You identify a lot of additional women and men, because we're talking about anal cancer, penile cancer. These are all also involved. So then we have what are called the worried well. These are people who go around anxious, they get depressed, they don't feel so good. So where the epigenetic test comes in is it is a very accurate way of telling which HPV infections are in fact carcinogenic.
Right, so we've got two problems here. There's the smear test, which isn't quite accurate enough. It only detects around 50%. And then you've got the HPV test, which detects a lot of it, but loads of those are kind of false positives. They're people with the virus, but who aren't necessarily going to go on to develop cancer. So there's a lot of money being spent, maybe where it doesn't need to be, causing unnecessary worry. So you found something that's like slap bang in the middle that can detect the cancer accurately, but only the ones that we need to worry about.
That's right. What we want to do is identify the people in whom cancer is very much on the cards, but we want to surgically remove those lesions before they become cancer. And that's the place where you have to be incredibly accurate. What you want to be able to do is minimize surgery, but maximize prevention.
What is epigenetics, and how does this test actually work then? What's going on?
Epigenetics is an intrinsic mechanism within the bodies of all animals, all living beings, that actually regulates how the DNA is decoded. So any given stretch of DNA is, let's say, dumb until it has an epigenetic code. The epigenetic code actually is like the conductor of the orchestra. It basically tells the body how to play the piece.
These epigenetic markers are like little tags on the DNA. And when this virus starts to get dangerous, it changes a specific type of the marker, which means that the DNA will start to be read differently. And if the conductor isn't reading properly, it makes for an unpleasant composition. And so Attila's test can spot these changes in the DNA, and it gives a good indication if cancer is coming.
What we measure actually is the degree of abnormality and the change of abnormality over time. So people could have their methylation measured over the years and get a sense of, are they progressing in the direction of cancer, or are they progressing away from cancer?
Right. And do you think this could be used for other types of cancer?
I do. And we've worked on prostate cancer, and we've shown that it is quite accurate for predicting aggressive prostate cancer. I think that this test, maybe not the exact genes that we're looking at, but different genes, will be applicable to every human cancer. And it is now incumbent upon us to actually find which signatures are the best for which cancer.
Attila Lorenz from Queen Mary University of London. He was speaking with Georgia Mills, and the study they were discussing has just been published in the International Journal of Cancer.